Hello everyone, myself Professor Gokul Patil. Welcome to our YouTube channel. In this training video, we are going to discuss that how we are going to process the two-dimensional array, how that array is being stored in the memory, and how we are going to read that element from the memory. So first we will talk about the representation of two-dimensional array. Let's say my array A with size is 3 by 4. A simple array of 2 dimensions with size 3 by 4, that is 3 number of rows and 4 number of columns. And if array index start from 0, then it represents 0th row, first row and second row, while the columns 0, 1, 2, 3. 3 is the last index because the array index start from 0 and goes up to n minus 1. So 0 to n minus 1. But in some case, it may be start from 1. In many GATE exams, it is given that it should start from 1 to n. So that also we'll see. So first this example, that array index is start from 0 to n minus 1. So this is the location, that is 0, 0, 0 through 0th column and so on, 0, 1, 0, 2, 0, 3, 0 through, and then similarly for the next row, that is 1, 0, first row, 0th column, 1, 1, 1, 2, 1, 3, 2, 0, 2, 1, 2, 2 and 2, 3. So this is the arrangement of element in two-dimensional array. But these elements are not in sequence because it starts from 0, 0, 0, 1, 0, 2, 0, 3 and thereafter there is no element. In the next row again there is. So there is no linking or relation between this element and this element is directly, because there is no 0, 4 is there. It is been disconnected. So memory cannot be represented for this kind of data. So first of all, what we have to do, we have to convert this array representation into one-dimensional array. So we have to convert this two-dimensional array into one dimension. So every array is start from some base address and we have to convert it into sequence. That sequence may be either we can write it in terms of rows or we can write in terms of columns. So this two-dimensional array is being converted into one-dimensional by using two different order. One is row major order, other is column major order. We will see one by one. In the row major order, we will collect the element from each and every row and write it in terms of one-dimensional array. Suppose there are 12 number of elements are there total. We will write it in terms of one-dimensional array. In this example, there are 3 rows are there. So row 1, row 2 and row 3. So this is my 0th row, this is my first row, this is my second row. Each row contains 4 elements. So 4 blocks are there. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3 and 4. These 4 blocks are there. I write the locations, or we can say index of each and every row. So first is 0, 0, 0, 1, 0, 2, 0, 3. These are the 4 indices in the first one. And the second row, 1, 0, 1, 1, 1, 2, 1, 3. Then in the third row, 2, 0, 2, 1, 2, 2 and 2, 3. So we will write in terms of sequence, or we can say in one-dimensional array. Now if I want to find out the address of this element, at what address this particular element is stored, any element we can find out. We will take an example of this 2, 1. I want to find out the address of this location, that is 2, 1. How we are going to find it? And let it be the base address of this array is 100. So element is going to start by storing from address 100. It is a random location because address is always in hexadecimal. For understanding purpose, here we will take an address is 100. Now we have to find out the address of this particular location, that is 2, 1, by using row major order. So first we will talk about the row major order, and I have to find out the address of this location 2, 1. This is very simple. to find out the address of any particular location in two-dimensional array. First of all, we'll check that how many rows before to this row. So there is 2 rows are there. So 2 rows are there. And how many elements it should cross in that 2 row? 4 plus 4. So each row contains 4 elements. So 4 element has to be crossed from the 2 rows. So row number 1, row number 2, and 4 element has to be crossed from each row. So 2 into 4 plus. How many element in the column has to be crossed? 1 element of the particular column has been crossed. So 1 element from that column has been crossed. So plus 1. So this is the total number of elements that should be crossed before visiting this 2 1. So 2 means 2 number of rows. 4 is nothing but 4 number of element in each column. Each row. So 2 into 4 plus 1 element from this column before visiting to this element. Multiply by this size of each element, because the size is nothing but data type size. How many particular size is required to store this particular element? So if it is integer, 2 byte is required. If it is character, 1 byte is required. So then let's say this is my integer array. So 2 byte is required to store each and every element, plus the base address, that is 100. From at what point it starts by storing the element, and that is 100. So this is nothing but the memory location where this particular element is present. Now we will calculate that. 2 into 4 is 8, plus 1 is 9, into 2, that is 18, plus 100. So that address of the element is 118. We will also cross check this with the help of this sequence. First element is stored at address 100, 102, 104 by 2 bytes, because it's an integer. As we mentioned, the size is 2. So 100, 102, 104 and so on will increment with 2 bytes. 106, 108, 110, 112, 14, 16, 18. So it is exactly, that is 118. So in this way we can calculate the address. We can extend this with the help of formula, so that you can remember that in terms of R and G. My array size is, let's say, m into n, m number of rows and n number of columns. And now we have to write in terms of formula that how we can read this element in terms of ig. So plus something, this is multiply plus this, I write it the format, and then I'll put it in terms of R and G. So 2 number of rows has to be crossed and 4 number of elements. Now we will write in terms of formula I into J. So I want to find out the location 2 1. So first it should be crossed with 2 number of rows. So I into total number of element in each row, that is nothing but the 4. So 3 by 4, 4 number of columns are there. So each row contains 4 elements, because this is the sequence that 4 columns are there. Each row contains 4 elements, and there are 3 rows are there. So I into n, I is nothing but the how many row has to be crossed, and n is nothing but the number of element in each row is to be crossed. That is, then total number of column element, that is j, has to be crossed, that is 1. Only 1 element has to be crossed. So j is nothing but the second index, 2 1. So 2 is nothing but number of rows, and j is nothing but number of column has to be crossed, plus size. It's actually data type size. What data type you are using, that much size you require. And then finally the base address. Once we write this, then we'll again cross check ij. I is nothing but the row and j is nothing but the column. So this I stand for row and j stand for the column. So say 2 row has to be crossed with 4 element in each row, plus number of column, that is j, 1, plus data type size, that is 2 byte, plus base address is 100. So you can apply this formula anywhere to calculate the row measure. So this is the calculation for row major order. It is very simple. One more thing that I have to mention here. If the array starts from the first index, not from the 0th index. So if it starts from the first index, see here I write, if the array starts from the first index, that is 1, 2, 3, a similar array size, that is 3 number of row and 4 number of column. So 1, 2, 3 and the 4. Element has to be stored at in location 1, 1, 1, 2, 1, 3, 1, 4. Then 2, 1, 2, 2, 2, 3, 2, 4. Then 3, 1, 3, 2, 3, 3 and 3, 4. It starts from the first index instead of 0 index. So what sort of modifications are required here? We are again take the same element, that is 3, 2, which we consider in the first example. So we can write the calculation for 3 of 2 in terms of ij is nothing but I minus 1. One value has to be subtracted, that is 3 minus 1, you will get 2. 2 minus 1, you will get 1. So if I subtract here I minus 1 into n, then plus j minus 1 into size plus base. So we have to subtract 1, 1 if the array index is start from 1. Otherwise it start from I and j, that is 0, 0. If it start from 1, then we will subtract 1, 1 from the both indices I and j. So we will calculate the location, we will calculate the address. If it start from 100, 100, 102, 104, 106, 108, 110, 112, 114, 116, 180. So now we will calculate with the help of this formula, A of 3 of I2. So what is value of I is 3, value of j is 2. So here I write 3 minus 1 is 2 into what is the value of n, number of element has to be crossed, that is 4, plus j minus 1, j is 2, 2 minus 1 is 1 into size, that is 2, plus base, that is 100. 2 into 4 is 8 plus 9 into 2, 18 plus 100. So it is 118. We will get the same result in both the cases. So if the array index is 0, then also we can calculate the address. If the array index is 1, we can calculate the address. Both the methods are easy. No need to mug up this formula. If you remember the technique, that how many rows and how many elements are there that we have to cross, then we can easily find out the address of each and every element of the row major order. We will see that how we are going to calculate the address by using column major order. So we will see the column major order. So first of all, the element we have to write in terms of one dimensional array, because it is not in the sequence that we can see 0, 0, 0, 1, 0, 2, 0, 3, there is no 0, 4. So it is in the next one. So first task, if you want to read that element from the memory or from the data bus, then we have to convert it into one dimensional array. So how many columns are there? 4 columns are there. So I write this element in terms of column wise. This is my first column, second column, third column and the fourth column. Each column contains 3 elements. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 2 and 3. So this is my 0th column, first column, second column and third column. Array index is start from 0, so that's why 0, 1, 2, 3, total 4 columns are there. Element in that 0, 0, 1, 0, 2, 0. In the second column 0, 1, 1, 1, 2, 1, 0, 2, 1, 2, 2, 2. Then 0, 3, 1, 3, 2, 3. Now once the element is going to be right in terms of one dimensional array, then we have to find out, let's say same example we'll take again, that we write for the row major order. I have to find out the address location of 2, 1, where this particular element is stored in the memory. we have to calculate the address of 2 1. So we will write here A of 2 1, but now it's by using column measure order. So this element is stored at this point. The array is having n number of rows and n number of columns. So 2 1 is there. So how we can write this in terms of calculation first. So how many column it should cross to visit this element? So there is a one column that is been crossed. So one column has to be crossed. How many element in that column? So 3 element in that column. So 1 into 3. One column and 3 elements should cross. So 1 into 3 into plus. We have to add all these things. 1 into 3. One number of column, 3 number of element has to be crossed. Then how many element it has to visit in the next column? So before going to visit this, 2 element has to be crossed. So 2 element has to be crossed. Then the size of data type. Here size is 2 because we are using integer data type. And then the base address, that is 100. So starting point of the array, or we can say the base address of the array is 100. From then onwards it store the element. This 100 is for the understanding purpose. Generally all the addresses are in hexadecimal. For understanding purpose we will take the example 100. Now we will substitute the values. Now we calculate 1 into 3. Now we calculate the answer. 3 plus 2, 5 into 2 is 10, and 100, that is 1 1 10. So at this location this particular element is stored. Now we will cross check that the first element is stored at location 100, next will be 102, 104, 106, 108, 110. So here I will get the location 110. At that location this particular element is stored. So this is the way that we can calculate the column measure order. We will write in terms of I and j. So let's say A of ij, so that I can calculate for each and every element of the array at what address it is been stored. So m number of rows and n number of columns. So initially how many column it has to be crossed? Column is nothing but j. This is my row script, this is my column script. So how many column is to be crossed? One column. How many element in that column? 3. So 3 number of elements in that column. Plus how many element it has to visit before visiting to this 2 1? So 2 elements in that row. So I. So also we can say 2 number of row has to be crossed. So we can write 2 here. We can say 2 number of element or 2 number of rows. Then multiply with size of the data type plus base address. So this can be extended in terms of formula like this, so that you can able to calculate the address by using column measure order. If the array index start from 1, then we have to subtract 1 from I and j. So hope you understand this, how to calculate the column measure order by using any particular array, 2-dimensional array. First of all convert into 1-dimensional, and then it has to be checked. Then it has to be checked the number of rows and number of columns it has to be visit, and then we have to write in terms of formula. So this is all about the row measure and the column measure order. If you like the video, kindly share and subscribe the channel. Thank you so much.